The last topic we're going to cover in this chapter in Systems and Equations is going to be systems of linear inequalities. So again, a system of linear inequalities will be two or more linear equalities graphed within the same plane. Now, a solution to the system is any and all ordered pairs that satisfy the inequalities. And remember, when we previously graphed linear inequalities, we saw that we had to shade the coordinate grid for the area that contained all the points that were solutions to the system. And what I want you to remember is we covered intersections and unions of systems, where intersection is where the solution sets were in common. And the intersection is actually just the solution to a system of those linear inequalities. So what we're going to be doing is just graphing intersections again. So let's go ahead and graph each of these lines. Again, I find it easiest to put these into slope-intercept form, make it much simpler to graph these. Our first one's already in slope-intercept form. We have y is less than or equal to 3x. So we start at our origin, and we have a slope of 3. Now remember, we have dotted and solid lines for our system, so we need to make sure that we're paying attention. These are or equal to, so this will be a solid line. And there is our line. Y is less than or equal to 3x. And this line is shaded below. We'll shade below. But we need to see where our other line is to see where the intersection is. We can rewrite this equation into y is less than or equal to negative 1/2 x plus 4. And so we'll start up here at 4, and we've got our negative slope. 2. It is also an or equal to. So we'll have a solid line. And here we go. This is x plus 2y less than or equal to 8. And because it's less than or equal to, this one is also shaded below. And so what we can do is if we're shading below both of these lines, that is going to be this region inside this area here, below both of these lines. So here's our shaded region. And of course, we can check to make sure that our shading is correct by picking a point somewhere within the shaded region. Let's take a simple point here. We have the point 5, 0. If we plug 5, 0 into our equation, well, we get 15 is greater than 0, so that's true. And then we can plug in 5 plus 2 times 0. And we see that 5 is less than or equal to 8, and so our solution is valid. We've shaded in the correct area. Go ahead and try the next one. Slope-intercept form already. And we can rewrite this one as y is greater than or equal to negative 1/3 x plus 2. We'll graph our first one. This is y is less than or equal to 4x, so we're going to shade below. And here, another solid line. X plus 3y is greater than or equal to 6. So this one we're going to shade above. So we want below the red line, but above the green line. That's going to be this upper area over here. We could check our answer by verifying a point in our solution. We could see that 4 times 5 is greater than 5. And we could see that 5 plus 3 times 5 is also greater than 6. So we know that our solution is probably correct. Now here we've got a system of 3 equations, so we're going to plot all 3 of these and then see where our shading overlaps. So our first inequality, we can rewrite into slope-intercept as y is greater than x minus 2. Remember, we're dividing by that negative, so our inequality has to change directions. Let me write that a little bit neater. X 2. Our next inequality, we can rewrite as y is greater than negative 1/2 x minus 1/2. And then y is less than 2. Well, that's just going to be a vertical line. So let's go ahead and graph each of these. We'll start with the first one at negative 2, and it has a slope of 1. And because this is not an or equal to, it's just less than, then it's going to be just a dotted line. Place a dotted line going through there. So there's our y is greater than x minus 2. And because it's greater, we're going to shade above. Next one, we actually have a y-intercept of negative 1/2 and a slope of down 1, right 2. And again, it is a dotted line. Y is greater than negative 1/2 x minus 1/2. And again, we're going to shade above. So far we're looking at this area up here somewhere for being shaded. Now let's look at our last line. Let's do that in purple. We have the line y is less than 2. So that is a horizontal line dotted again at y equals 2. And because it's y is less than, we're going to shade below. So we're shading above these 2 lines and below this one. That's this little triangular area here in the middle. So our shaded region is going to be this spot within here. Now we could check our solution by plotting a ordered pair and seeing if it's valid. Let's take a nice easy point like 0, 0. Well, if we take 0 minus 0, is it less than 2? Yes, indeed it is. If we take 0 plus 2 times 0, is it greater than negative 1? Absolutely it is. Is 0 less than 2? Indeed it is. So we know that our shading is probably correct. This last one has 4 inequalities. So we'll have to draw 4 boundary lines. We'll start with our first equation in slope-intercept form. Y is less than or equal to 3/4 x plus 3. Let's go ahead and just graph that. And it's an or equal to, so we've got a solid line. Next, we'll go ahead and graph our x is less than or equal to 3. That is a vertical line at 3. There we go. Solid line again. So that is x is less than or equal to 3. So we're going to shade left on this one. And on our first equation, we are going to shade below. So far we're below and we're left. So we're going to be somewhere in this area for our shading. So let's take a look at where that's going to be. Let's graph the next one. X is greater than 0. That's a vertical line at 0. Solid line, greater than or equal to. X is greater than or equal to 0. So that means we're going to shade to the right. So we're below here, we're left here, and we're right here. So we're shading somewhere in this column. Let's go ahead and graph our last one. Y equals 0. Well, that is our y-axis right here. Y is greater than or equal to 0, so we're shading above. So we're left here, down here, right here, above here. So that gives us this quadrilateral space here, this little trapezoid looking thing in the middle. And to verify it, again, we could pick a point in here and test it, such as the point 2, 2. And we could say, well, is negative 3 times 2 plus 4 times 2 less than or equal to 8? Well, negative 6 plus, 12. Negative 6 plus 8 is less than 12, so it satisfies that equation. 2 is less than 3, so it satisfies that. 2 is greater than 0, so it satisfies that. And 2 is greater than 0, so it satisfies that. So we know that our point is good. So again, this is more of a review when we did our graphing linear inequalities in two variable, because a system of inequalities is just like an intersection of two or more inequalities. The only difference is now we're adding in a couple more inequalities, so you could graph 3, 4, or 5 and see where the intersection lies.